It's recording.
So Michael, again, thank you for volunteering, being part of our Utah Kubernetes meetup tonight. We're excited to hear from you. A lot of us have been doing some stuff in Kubernetes for a while, and those that are in companies have always been asked, well, how much are we spending and who's spending the most? And there's never been a great answer. So we're excited to hear the answer from Michael. So I'll hand it over to you. I've already asked Michael if it's okay about Q&A. Then he said just interrupt. So, and then also we have a Q&A at the end. So Michael, take it over.
Thank you very much. So I'll share my screen here, and while that's loading itself up, I'll just reiterate that totally fine to interrupt me at any time. I know we could be at like any different levels here. So if I'm being way too complicated, just let me know. If I'm explaining way too much, let me know. Drop questions. I'll try to keep an eye on chat, or just, as Paul said, interrupt me at any time. We'll get through the slide deck pretty quickly. Then I'll go through a demo. And yeah, let's get going. So I'm Michael Dresser. I work at a company called Stackwatch that makes a product called Kubecost, which is sort of what we think is the sort of one-stop shop for cost monitoring and management for Kubernetes. This deck is really just about like concepts we think are good to understand when it comes to managing cost in Kubernetes. And I think, I'm not trying to be too sales pitchy here, but there's definitely some of that baked in. So a little bit about me. I'm a software engineer working on Kubecost. I've worked on Kubernetes since, I don't know, something like 2019. And I was, for a little while, an open source contributor to Kubernetes, specifically doing SIG testing stuff. This looks like a lot, but very high level. What I'm going to talk about on this deck is what is Kubecost. I'm going to talk about what we call the cost model for Kubernetes, which contains some stuff. Talk about cost management in Kubernetes. So once you know how much stuff costs, as well as some extra data, how do we actually use that, including reducing the amount of money we spend. Then we do the demo, Q&A, of course, interrupt me at any time. So what is Kubecost? It is a cost monitoring and management tool for Kubernetes. It's used by companies like GitLab, Adobe, Capital One, many others. I think the current number, this is rough, it's certainly higher than this, but we help our customers monitor over $2 billion of cloud spend. We've helped customers save millions of dollars with cost management stuff. We are purpose-built for Kubernetes. So the idea is we run anywhere Kubernetes runs. And I think this is really true. So this is even in air-gapped environments, we have been deployed and used successfully. It's free for small teams, deploys on your cluster, no data egress. If you're interested in a SaaS option, talk to me. That's sort of in beta right now. And it's open core. So a ton of our code, including many of the front ends for the product, are open source. So you can go to our GitHub, which I think I will link later if you want to check that out or contribute and check us out. So let's talk about the cost model. And the cost model is, in essence, the way Kubecost thinks about cost. And we think it's the right way to think about cost when it comes to Kubernetes. So this is, in more friendly terms, how much does my cluster cost? How much does my namespace cost? How much does my label cost, et cetera? So we basically consider two components of cost: asset cost and allocations. Asset cost is actually the thing that you get billed for, usually in your cloud provider's billing report. So this is like your nodes, your disks, and we'll pull that from cloud provider billing APIs or billing reports. And then we talk about resource allocations, which is sort of the Kubernetes side of the cost, right? Kubernetes is this awesome abstraction that lets us just say, hey, I want to run 50 of this container and I want it to use, 2 CPUs each and spend a ton of money. But it's nice because it just kind of works and you kind of get abstracted away from the physical thing that's costing you money. So we sort of make that connection by unifying the concept of an asset and the concept of an allocation, which contains things like, cores used, cores requested, network bytes sent, and all sorts of other metadata. Really quickly, I want to talk about what an allocated resource is, because as I'm sure many of you are familiar, you can set container requests in Kubernetes, which is sort of a pre-allocated block of CPU or RAM that a container is given by Kubernetes. It's scheduled and is technically sort of mostly ensured that you get that. And so even if a process that in a container is only using like this green bar, if the process is only using like 3 cores, but you've requested 4 cores. From a Kubernetes standpoint, you're still responsible for like 4 cores of cost. And I think this will get pretty clear also as we dive into the product itself. But it's a really important thing to understand is that a process's consumption is not the same as the actual resource that an actual pod is spending through its container requests. I want to briefly talk about resource units. I think this is like a technical thing that we can maybe come back to as we get more questions, but it's basically like, what are the units of cost and all that jazz. We basically take variable stuff like CPU usage here, and we take an average and turn it into core hours, like CPU core hours or RAM byte hours or something like that, so that we can aggregate it nicely. This is a nice statistical trick we can talk about more later. The same allocated resource concept here. Again, this is the amount of a priced resource that a container is responsible for, which is not the same as the amount of a resource that a process is using. So at the end of the day, right, the cost of a workload on Kubernetes is the amount of allocated resources times the cost of those resources. And if we have nice units, this math actually works really quite this simply. So just a brief overview of how Kubecost works. You can hit me up here and we can talk about this, or we can go back to it. This is a pretty simple diagram. I should say vastly simplified, but gets the idea across of how we get all the data we need. So there's resource usage data. This comes from Prometheus or a Prometheus-like database if you're using something like Thanos or Cortex to do more fancy stuff. We get resource cost, usually from your cloud provider, either through their public APIs, or you can get exported billing reports that have your exact cost for a given day and a given node. And then we get some workload metadata from the Kubernetes API, feed that all in to the magic formula, and we get out what we call an allocation, which has metadata about the workload, so namespace, pod, container name, that kind of thing, the resources used, requested, etc., and then the resulting cost that we've calculated from all the data we've gathered. And then the nice thing about this sort of model, especially with the monitoring stack that comes with Prometheus, is that we have sort of near real-time estimation, and then after a day or two, we get sort of exact costs of your Kubernetes workloads. I think, again, this will get a lot clearer when we get into the UI. I also want to mention idle capacity. So again, we have our allocated resources, but then of course, if you have, say, 40 CPUs available in your cluster, but maybe you're only allocating 20, you have an amount of idle CPUs. And if you know the amount of idle CPUs and the cost of the idle CPUs, you can do the really easy math and figure out how much money you are wasting on your over provisioning. Of course, there are cases where you might want to over provision because you want some room for failing nodes or bursty workloads or auto scaling and things like that. But in general, very high idle is often a bad thing. And we can also calculate that. So I'll just pause for a moment. If there are any questions, I can take them now.
I do have one.
Yeah.
Is it natively supporting multi-cluster, or do you usually get, if you say had a fleet of clusters with namespaces that all represent the same workload, is it able to sum it up across multiple, or does it kind of assume single cluster or have limitations on single cluster?
Right. So we work in a multi-cluster way. Totally fine. This is like an enterprise paid thing because there's a little extra setup. If you like, I can sort of flip over to an actual better architecture diagram because the more exact like architecture diagram here is in a single cluster regular deployment that's like totally free for everyone is this one where you install Kubecost. It talks with some stuff. It reads and writes data from Prometheus, and we produce all that cost data. But in a multi-cluster environment, it's a little more complicated, but it looks something like this, where I get that this isn't like super helpful, but essentially we have all of the data at the end of the day gets put in Prometheus or in a sort of enterprise multi-cluster setup in Thanos, so you can have federated sort of data stores, and then the Kubecost application that's serving the UI and the API is just talking to all that Thanos data. So we totally support multi-cluster. There's just a little bit of extra setup because you got to ship the data around, and that is a non-trivial thing. And we can totally talk more about that if you want.
No, that's great. Thanks.
Yeah.
I had a question. So
Yeah.
with things like cross-plane or with GCP, the like config connector and those type of things, you talked about the costing of the cloud. I mean, you get from the cloud, you get the billing and all the other resource stuff. Is there a way of actually then tying with I'm talking with cross-plane?
Yeah, I was talking with guys at Crossplane actually at KubeCon. So yes.
Yeah. So is there a way to actually count from a Kubernetes side, the costing of like the resources that you may be allocating via like a crossplane? I don't know if that makes sense to you, Michael.
Yes, it does make sense. So we talked about this a little bit. I think both the crossplane people I talked with and sort of we at Kubecost, we both think there's a lot of potential here, and we're both not quite far enough in maturity in a couple different dimensions to like perfectly sync up that picture. But the idea is there. I can show you when we get to the demo sort of how we deal with sort of out of the cluster costs and how we can in a pretty useful way right now, but not quite to the level that you need for crossplane, tie those costs back to Kubernetes concepts, right? Because if you're doing all of your infrastructure management like in the Kubernetes way with crossplane, which is super cool, you'd want to sort of make those costs connect. I think we're planning on sort of reconnecting with them in a month or two, see if we can make an integration happen. But right now it might sort of work, but it's not going to be great.
Thank you.
Would it still work, assuming you had the perfect namespace or label matching, that you would aggregate up to a label or namespace instead?
I think so. I think if you just set up your metadata correctly, it would connect. You have to basically tag your out of cluster resources with a certain tag that we look for to sort of assign that out of cluster resource to an in cluster concept, whether that be a namespace or a pod or a container or whatever it may be. But you just have to make that connection on labeling out of cluster stuff with the right in cluster tag, or whatever that may be. Okay, let's just keep slugging away. So basically, this gives us the cost picture of how much stuff is costing, and we'll see what that looks like in the demo. Then there's also like cost management. So this is like how we at Kubecost see our users using this cost data and features we built to sort of improve that experience. I think the concepts apply much more broadly than Kubecost itself. If you wanted to build a copy, like you can do all this. It just it requires a lot of data and some thinking. So the main thing we see that pretty much everyone wants to do is what gets called showback or sometimes chargeback, where it's pretty common to have your infrastructure or ops team separate from your developer team. They're creating and provisioning your clusters, but the developers are the ones putting the workloads on the clusters. Maybe your finance team needs cost data by product or by team. Maybe your developer teams have infrastructure budgets that you need to enforce or at least keep track of. So people often use this cost data to build reports for the various teams across the organization to sort of tell them how much they're spending or force them to take that amount that they're spending out of their budget for infrastructure, whatever that may be. Another thing people do that I think is quite popular, as I've mentioned before with the millions we've saved, is savings. This is basically taking all the information we have about your cluster, the workloads on it, and how much everything costs to try and identify some changes you can make to reduce the cost. I think the first one that makes a lot of sense is just over provisioning the container requests. When I first started in Kubernetes, I was on a developer team and the ops team said you have to put container requests on all of your YAML. And I was like, all right, cool. I'll just pick 3 CPUs and 4 gigs of RAM because that sounds like it's enough. And I don't know what my sort of actual production workload profile looks like. So I'll over provision it to make sure it runs well. And it's a good best practice, right? So then your containers don't get evicted for using too many resources or that kind of thing. But as a result, you may end up with a lot of over provisioned cluster capacity that's not doing anything. It's being blocked off. This container gets 4 gigs of RAM, but it only uses 1. But the Kubernetes will essentially never schedule anything on top of that because it's been over requested. So you can use the breakdown of request and usage to sort of shrink the request to be more in line with the usage, and you can save some money there, or at least save some capacity. You can sort of realize the savings essentially by taking that idle capacity we were talking about earlier. And this is obviously a very simplistic example. I think you could pretty easily write like a kubectl command to figure out if a node had nothing scheduled on it. But the idea is if you have over-provisioned capacity that you don't need, you can put a dollar figure on that, especially in a more complicated case where maybe you have like high CPU nodes, but you're not actually you're using all the RAM and you're not scheduling anything because you have no RAM, but you have a lot of CPU left over. This is the kind of thing you can also do where if you're aware of the rough profiles of all of your the containers on your cluster, therefore all the workloads on your cluster, you can make a more intelligent choice about which node types you use as well as quantities. And then lastly, and there's plenty of else we can talk about here, but there's like abandoned workloads. So Kubecost can also gather network traffic, and we use a heuristic that we think is okay, is that if a given container pod is not dealing with a lot of network traffic, it might just be abandoned. I've definitely spun up pods on dev clusters and just done some useful things with them and then let them sit there over the weekend and forgot about them, which is just wasting capacity. So we use a heuristic of network traffic to try and identify where you have abandoned workloads, and you can just cut them out, save some money. And lastly, governance. I think we can go a lot into this, but it's basically, I'll highlight 2 areas: are alerts and just automatically preventing over requesting through automation. So alerts are things like just, hey, I want a weekly update to all my developer teams of how much their namespaces or their labels are costing them, if they exceed certain spend thresholds, efficiency thresholds, that kind of thing. And we've also seen a specific integration with Spinnaker where they use Spinnaker, the CD tool, to basically deploy their workloads and then watch them for a while and then ask the Kubernetes API, the Kubecost API, if they can recommend a better request, and then it updates the deployment like live in the cluster to do that, which is pretty sweet, I think. I'm going to jump into a demo now, which I think should answer a lot of questions, but I'll pause again if there's any more questions.
You mentioned near real time. What is that kind of feedback loop? Is it a minute, 5 seconds, an hour? What's a real time kind of boundary there?
Yeah. So Kubecost, the product itself, it's sort of a game of accuracy. So Prometheus, you'll set your scrape interval to whatever it may be, but say it's like 5 seconds. Kubecost builds a sort of performant cache of that data roughly once an hour, but tries to update a little more frequently. It'll be an estimate until we get more accurate cloud provider data. So the idea is as soon as metrics are available in Prometheus, Kubecost can start building a picture for you. It'll talk to the cloud provider APIs and things like that to get estimates of what the price should be for a given node, for example. But it's often the case, like for example, with Amazon, they have a cost and usage report. I think Google has an analogous thing that comes out. Like we've heard it's 6 to 48 hours, depending on scale, afterward, and it gets continually updated for like a month. But as soon as that report comes out, we basically we go from like plus or minus 10% accuracy, which is like every hour, to plus or minus like 2-3% accuracy. And then in theory, if the billing report gets finalized, we're like plus or minus 1% accuracy. But it's all a game of increasing accuracy as better data becomes available. But near real time is roughly on the hour scale or shorter.
Cool, thanks.
In certain cloud providers, AWS, I think GCP also has that, they have this notion of a spot instances and such. And then we've used tools in the past that kind of, uses, I don't know if you're familiar with the spot termination helper, anyways, there's stuff out there that kind of looks at things and then it kind of determines, hey, I can use a spot here, or maybe I shouldn't use a spot here. How does that all work in? I guess, like you're saying, the granularity would be an hour, but does it kind of help you determine if that's a good strategy? I know it's all dependent upon your workload and all that stuff, right? But how does that work with like those type of operators and or tools for spot instance management?
Yeah, so spot instances are kind of hard to deal with because, in theory, like it's great for Kubernetes, right? Where, you have the scheduler that'll just handle like, hey, my spot instance goes away. Maybe I spin up a new one and all of my workloads get rescheduled. That's awesome. There's stuff in, I think it's like Kubernetes like 1.21 or something like that, which like allows you to more gracefully handle like node termination in like the case of spot instances and things like that, which is really cool. We don't have any direct integrations with like the actual automation tools that do what you're talking about, but I can show off a little bit of spot, sort of a foray into spot savings that I did specifically, so I can talk sort of at length about it and at length about its drawbacks in a few minutes.
Okay, thank you.
Yeah. Okay, so I'm gonna jump into the demo. This is a live cluster on AWS. It looks basically the same on GCP. Everything I'm gonna show you is in the free version of the product. You can literally like run a Helm install. You'll be running in roughly 2 minutes. You can go to kubecost.com/install. You got instructions there. Again, like I mentioned, it's open core. So what I'm going to be showing you is half open source, half closed source. It's built together, of course, as those things are. But a lot of the code, and especially the math and the Prometheus queries we run to get a lot of our data, is all public. So I am in a live version of Kubecost. This is sort of the core page, I think I would call it. This is the cost allocation page. Right now I'm showing a breakdown of cost over the last 7 days, broken down by namespace. So like the Kubecost namespace is like, I don't know, $16 in the past week. So this isn't a huge cluster or anything like that, but it serves demo purposes pretty well. We have all sorts of aggregations here, right? Namespace is a very common one, but we have things like label. We have things like cluster and a multi-cluster sort of enterprise deployment, and all sorts of other breakdowns if you want that kind of stuff. We have some various filters that I think we'll come back to in a moment. We can, of course, drill down into cost by namespace. So we have cost, CPU cost, GPU cost, RAM cost, PV cost, network cost, load balancer cost. This is all sort of in cluster cost. And then there's shared and external cost. Like I mentioned earlier, I think a question was, we can tag out of cluster resources with like, it's something like Kubecost namespace, Kubecost equals Kubecost or something like that in your sort of out of cluster assets. And it'll get pulled in here and added in with this cost, so that, the Kubecost namespace, I think, has some S3 buckets associated with it. And so we're tying that cost in, and that shows up in our total there. We can drill down here into by controller. So these are things like our deployments, daemon sets, stateful sets, etc., that are in our Kubecost namespace. You can go with it even further, see the pods in the Kubecost deployment. And one more, and we can see that thing I was talking about earlier, where we have like the amount of the allocated resource times the cost of the resource, and we actually can see all that data here. Kubecost is going to show it to us. So the cost model in this window is running for like 107 hours. It was averaging an allocated resource amount, so that's the max of usage and request, of 0.2 cores. And according to our cloud provider, which is Amazon in this case, we're paying like 3 cents per core hour, which is not bad. And then there's a bit of an adjustment because the cost and usage report from Amazon has given us a better number. And so we get an exact cost that should add up nicely. And so that's that same formula sort of going to play here, where we have the amount of the resource, time it's running, and the hourly rate of the resource. Cool. So that's cost allocation. I'm going to jump back here to sort of this main view. We have really quickly, we have things like reports, where maybe you set up a bunch of filters because you have a chargeback scheme and you want to maybe regularly report to team X or report cost by team to like some other team. You can build up a report, which is sort of a preset bit of It's a preset sort of set of filters and aggregations. And then you can hit that up with the API. You can download it as a CSV, all that jazz, whatever data format you want. JSON, send that where it needs to go. We see a lot of customers integrate with like BI tools where the ops team might be, managing the cluster and installing Kubecost because, some other team on the business side of the organization needs answers to some questions. And gosh darn it, they don't want to use another dashboard. Well, we have an API and you can script everything you want to connect the two. Right. So this is sort of the allocation side. We'll sort of jump backwards to the asset side. Kubecost the main thing that's important to get Kubernetes cost is your node costs. But we also, since we're getting the data anyway, can show you a little bit about other things running in your cluster, like Athena or S3, Amazon Prometheus, that kind of stuff. But we can look here at like Amazon EKS and we can actually find the specific cluster we're on. And this is how much we're spending on that cluster in whatever window we've selected. All well and good. These are like management costs, right? But these are the things at the end of the day, like EC2 instances are actually underlying nodes. These are the things that at the end of the day are on the billing report. Cost allocation uses that data to populate its cost information. We talked about idle, and I can actually show you what this looks like in the graph. So right now we're just seeing these are the cost of each of our namespaces. So on like the 13th, all of our namespaces on this cluster cost about $13. Not bad. But if we show our idle costs, right now I'm hiding them, I'll switch them to separate. We can see that actually we've like doubled the cost on this day. And that's because we had idle capacity in the cluster that wasn't being used by any of the actual workloads. It wasn't allocated. And that does have a cost associated with it. And it turns out it was like half of the cost of that day. So that's not awesome. But of course, as we talked about, we have savings strategies that we can use to make that number smaller and our overall cost number smaller. Again, there's that request right sizing idea where we look at the actual usage of resource usage from a container. Then we look at the request that you're setting. Oftentimes there's a delta between the two that we can say, hey, even with like a safe threshold of like maybe your workload spikes a little bit, even with a safe threshold, you can probably save a bunch of money. In this case, we're not saving a ton of money because we've already done some own sort of dog fooding optimization on our own clusters. But you can see things like here we're actually identifying that this RAM is, there's no request at all. And we think you should probably set one because you could get evicted. But also you're over requesting CPU. So overall savings of about $8 a month, that kind of thing. So we do this in the CPU and RAM dimensions and not any others. But yeah, that lets you sort of lower your allocated resources if you're over requesting. Then you combine that with right sizing your cluster nodes. So this is, again, profiling all the workloads on your cluster, not one by one, and trying to basically reduce that idle number by changing the instance types or instance quantities. So we've got some savings recommended here of like $60 or $100 a month, which is pretty good. What's up?
Michael, Pedro had a question in the chat.
Oh, yeah. If I use multiple cloud providers, I should set up a Kubecost instance per cloud provider, correct? What would be the recommendations for same cloud provider but different regions? Okay, so the way Kubecost works right now in a multi-cluster environment is you have to install a version of Kubecost in every one of your clusters. It's basically a primary-secondary relationship where the primary cluster is managing the API and the UI, and the secondary clusters are doing all of the cluster-specific data processing. You do have to pay like the enterprise for the enterprise product to get this multi-cluster functionality, but basically you install an instance of Kubecost in each one of your clusters. You configure it appropriately. All the data gets centralized in one place. And then we will serve everything from this UI you're looking at right now. And just about every feature works in a totally native multi-cluster way, except some of the more experimental stuff. Same cloud provider, different regions is the same answer as different cloud providers. Is just like your multi-cluster, so it all looks the same. You just have to you might have to set up your integrations. Like you'll need one AWS integration, one GCP integration, one Azure integration, to make sure you're getting all the appropriate billing data from your providers.
So that would be your recommendation then, is not, because if I'm doing like between cloud providers, it means I'm basically.
Yes, I don't think cluster sizing recommendations will work across clusters or cloud providers. I haven't run this in multi-cluster yet. You will probably have to run like this specific view on, sorry, it's been a while. This is the drop down for multi-cluster. You just change your cluster because assuming, we're talking either with the cloud provider's public APIs and or data dumps we have about like what their instance types are, how much resources each instance type has, and how much they cost. So we can sort of unify that with all the usage data we have and just produce a recommendation for each of your clusters, as long as you have it, set up and configured appropriately in a multi-cluster way.
My question was more, so I understand there's a lot of data collection, and if I have a lot of clusters, there's even more data collection, or a lot of workloads. My question was more like, if I have a lot of data, does latency really, is latency important? Like, or should I, or even, moving from one cloud provider to the other, I'm basically shipping data out from one and putting data into the other one, which also, adds up the cost. Does it make more sense to have one per cloud provider or one setup like you have here per region?
Yeah, okay, so this recommendation is pretty primitive, and so we're not looking at like per region prices and things like that, if that's what you're asking.
Yeah, it would be more the deployment model. How would you deploy Kubecost? Imagine you had 100 clusters, not a customer, but 200 nodes or worker nodes on 2 clusters in region A, and you had 200 in region B. Would you set up Kubecost like this primary, secondary?
If they're
like
all of the nodes are if it's on the same
you would recommend
cluster,
saying region A just has one Kubecost primary, secondary, and region B would have Kubecost primary, secondary.
So each installation of Kubecost should just be per cluster, and it doesn't matter, if the nodes are distributed across different regions or anything like that, because all the data looks the same, right? But the recommendations are going to be a little interesting, if I understand the question correctly, because like things like request sizing, right? Resource costs are just different, right, across different regions and things like that.
Yeah.
We do take that into account when doing a lot of our recommendations.
Okay, makes sense.
Okay, I'll pop over to the last bit of savings. Actually, we'll talk about one more because we got the question. We have abandoned workloads. I'll just show you this really quickly because we already sort of went over it. You just sort of set a network traffic threshold as a heuristic, do some analysis and say, hey, maybe you can kill this daemon set or this deployment because it's not doing anything. Of course, there are workloads for which they might not have any network traffic, but they're actually doing lots of stuff by like mounting a volume and then processing and then saving the data elsewhere. But just for simplicity's sake, this is like a nice heuristic to try and identify that stuff. But we did mention Spot, and there's a bit of a, Spot is really complicated, and I'll specifically call this feature out as like in beta and, take it with a grain of salt. But basically, we do some heuristics checks on all the workloads in your cluster and try to make a guess as to whether that workload might be spot ready. So a lot of people just use on-demand sort of regular nodes. They'll be alive all the time, but as we mentioned, the Kubernetes schedule is really nice in the case that your workloads just go away. And they just get, if your underlying compute goes away, you can spin up new compute and just reschedule your workloads onto the new compute or the excess capacity compute you have in your cluster. So Spot becomes really appealing because nodes going away and coming in is a lot more manageable than in other cases. So we made this feature to sort of test the waters in terms of making a guess as to what workloads are spot ready, and then making a recommendation where we sort of take that cluster sizing idea, but actually split it. So we try to schedule your not ready workloads onto regular nodes, and we try to schedule spot ready workloads onto spot nodes and make a guess there. It's pretty interesting. It's definitely beta, but we can totally talk about it more if y'all want to.
Do you include the preemptible label in the like final detailed export data? Like if you have a workload that is kind of run on two fleets, one being spot, one being normal, you're going to see much different costs on those. If you wanted to look at the detailed data, is there like a label or some flag that indicates here's what it costs for this pod when it was on a preemptible, or how does it kind of account for that workload that might be running on two nodes that actually cost quite different? Does it just shift everything to the full cost? How does it kind of rectify that or allow you to dive into it?
Yeah, so if you're already running, if it's already running workload that might be, say, split, like you said, between like on-demand and spot nodes, Kubecost is totally fine with that because we take price individually per node, and then the cost of the workloads running on that node is determined by the cost of the node that they are specifically running on, right? So if pod one of a given deployment is running on a spot node, its cost will be affiliated with the cost of the node it's running on. And if pod two of the same deployment is running on a non-spot node, it'll take the non-spot node's cost. And so when you aggregate them, they'll add together. It doesn't like take all of one or all of the other. Yeah, does that answer the question?
Yeah, could you see the cost separate? So like if you were doing forecast planning and saying, oh, we're going to switch to a new node type, we don't think we'll get many preemptibles out of it. Is there enough data in the detailed report that you could see, oh, here's my workload, it costs this much on spot and this much on demand? Is that a data field that's available? I'm assuming like it would just
right now.
Would it show up in the node type somewhere? Like the node, you would at least see that the node costs less, or you're saying you wouldn't be able to kind of see that difference between the two?
You would have to, if you got like the most granular level of data that we have, you could answer that question, but you have to do like a lot of manual processing of sort of because our core data is basically at the container level and includes sort of information about like node cost, right? That it's of like the resource cost of what it's running on. But it's not a thing in the UI where you can say like, okay, I want to split this workload's cost by the node types and see, how it's going.
Gotcha.
It's a really cool idea though. And we do have like a little bit here on like a bunch of bash that just gets generated because automating this is actually pretty hard and you need something like an operator to do this correctly. But if you just, say some patch your deployments with a toleration and make a spot pool with some taints, you can sort of stick it all together and it kind of works. Like I run all this myself and it's saved us some money, questionable amounts, but it works.
Is it still available through an API if you did want to try to, at least have a push button that did it for a user, or no?
This is not. I could not bring myself to productionize some hacky stuff I put together for KubeCon that could do that. It took a while because you have to wait for things to die and come up. Yeah. So right now it's still a manual process, but we're currently working a lot on automation. So taking these recommendations that we're making and like going to container request right sizing and just saying, okay, apply the recommendations. I think I trust you. That's relatively close to completion and should be out soon.
Is that data still available through the API? So like
yes,
you could see that. Gotcha.
Yeah. So everything, all the pages I'm showing you come from APIs that are, your standard HTTP, JSON APIs. Most of them are documented pretty well, I think. Some stuff is sort of kept a little secret just because we want to get some changes to it, but you can like reverse engineer from the browser console. But like, we have users who integrate directly with the request sizing recommendations and have for years just to automate their own like CD pipelines to do this kind of stuff before we ever got to it at Kubecost, because they really like our data and they want to spend less time manually going, okay, I got to find what cluster is this, and I got to go find the controller and just like apply this. They'll just, hit our API, get the JSON, and run it through whatever tool they have to do that. So that's a pretty common case. And that's the case for pretty much everything here.
Do you have that as a first class citizen? So like I know I've seen cost sizing information as part of GitHub PRs at like really advanced use cases. Is that something that you have like stable APIs that you would say, yes, it's good to build it on, or it's kind of a go as you want and there may be dragons where it may change underneath you?
I would say that the request sizing API is mostly stable. It is documented, if I can find it. Might be under savings. Okay, I'm not gonna live find this, I don't think. But it's out there. Here it is. Container request right sizing API. This might actually be better. We have this cool. Yeah, here we go. So model savings request sizing. That's what we're talking about right now. We've got all the parameters documented. And we've also briefly talked about like the methodology we use to make projections about savings, which is a little complicated, but if you're interested, we could totally talk about that because this is a lot of my work. And then, we have an example query you can run with curl against your Kubecost and get this data. I can't promise about the resulting schema is going to be perfectly stable, but the functionality and parameters and stuff is used by a lot of customers. So take with salt, but use it.
Yeah, well, it's at least documented, right? So that's good.
It is at least documented, which I can't say for everything. Yeah, we do see a lot of people using it. And of course, like this cost allocation page, like that has an API. Like all the cool core stuff you see, you can hit, you can build with the API.
Question about jobs, cron jobs, that type of thing. Are they just treated just like normal containers? And how does that work with, they kind of come and go, and times of the day? Do you have actually cost allocation or recommendations based on time of day, that type of a thing?
Yeah, so time of day, our modeling isn't that good right now. I think it's definitely an opportunity. Like cron jobs in general, we can totally like show you the cost correctly because we're just looking at like the container level and then aggregating based on the metadata tagging on that container. So it doesn't really matter like when or how it runs. We've done like the good time math to actually make this work properly. Now, if you have cron jobs that are like pods that run for like half a second, I can't promise anything because that's going to be like below your Prometheus scrape interval. So whether or not Prometheus like thinks it exists or not, hands in the air.
So that's how you kind of go into the radar if you want to not be charged.
Yeah. If you want Kubecost to not pick you up, I think it's a cloud provider specific how frequently they check if you actually have something running on a node. But yes, you could technically go under the radar, like avoid Kubecost cost by having like extremely short-lived pods.
Well, so like OpenFAS or those type, function type. How does that work also with Kubecost?
That does provide a challenge. Just because we rely on Prometheus for metrics, and therefore we rely very heavily on Prometheus's scrape interval, we can allocating cost for really short running pods is close to impossible for us. And so users with sufficiently potential users with sufficiently short running stuff will often do something more homegrown in the current state of things. It's something I think we'd very much like to support, but it's quite tricky because instead of relying on Prometheus, you're going to have to set like a bunch of watches on Kubernetes, like API objects, and correctly process like pod start, pod end events and things like that, which can get pretty hairy, especially when there's a lot of them running for very short periods of time. So we don't really do that.
Well, and it's got kind of diminishing returns on what that value can give. If they're that short-lived, I don't know. It's hard to even to track them in this way. They're
yeah,
because then the amount of space they take up on your nodes is kind of almost doesn't matter because it happens so little.
They're gone so quickly.
Yeah.
But we have seen people who run like almost all their workloads are super short lived, and they try to use Kubecost, and it's like it's not quite working, and that's it's an understandable limitation.
if you did have a node where that was a sizable amount of its workload, would it show up as a shared cost still, or would it be seen as idle? Like, would it actually fall all the way through and thought that it was idle?
It would
or
get seen as idle. If all of the containers basically start and stop in between Prometheus scraping the relevant metrics from that node, you're just they're effectively invisible, so they never ran. So that cost becomes idle cost.
Gotcha.
Also, what is the cost of the cost? What's the the Heisenberg, what's the overhead of Kubecost, and how does that, do you kind of amortize that across? I mean, if you're doing chargeback, do you amortize the cost of Kubecost across?
Yeah. So what people normally do is we have this shared column, which I didn't really talk about. And so you might have common costs within or without your cluster. This is things like Kubecost, infrastructure monitoring tools like the Prometheus monitoring stack might be one example if you run your own set. And you could pretty reasonably say that, hey, this cost really belongs not as its own thing. Like, we shouldn't just assign all of the shared infrastructure costs for all of our clusters. We shouldn't assign all that cost to the ops team, right? Like, that's silly. Instead, we should share it across the workloads running on the cluster, right? So every team gets a share of that cost equal to how much money they're spending. So we do totally support that. So if Kubecost is a shared infrastructure service, I would say it probably is. I could put, I could write Kubecost here, Kubecost. And if all goes well, we have a custom shared resource, which is the Kubecost namespace. And we can see that Kubecost has now disappeared from these sort of rows, and its cost has actually gone into the shared column. And so it gets shared proportionally according to how much spend each namespace had. And you can do this for all sorts of different aggregations and labels and things like that.
That's cool.
Yeah, it's a very common use case.
I don't know if you're going to get into this. Not that anyone has bare metal anymore, but some people do. How do you figure out the amortization costs of your hardware and all that type of bare metal?
Yeah. So the simplest way we do bare metal cost, right, is we just say, hey, give us a little very simple price per node, and we'll just apply that. But we also have a more advanced it's like a formula or something. I haven't done a lot with our enterprise customers on this, but we have a formula and I think in our documentation somewhere where we help you sort of determine the amortized hourly rate of given resources. Yes, legacy Kubernetes, indeed. I was there. My first place I used Kubernetes was on bare metal.
Absolutely. Thanks, Todd.
Yeah. But so we will help you a little bit with the finance side of that. And sometimes your finance team has already decided to want a formula for that, and they just give you the numbers, say, hey, this machine costs this much a month, and figure it out.
Thank you.
Any other questions? I'm happy to just talk shop too, if we want to get past all the cost stuff.
Do you have customers that are using the enterprise version of this to do multi-tenancy billing of a SaaS product backed by Kubernetes?
Okay, so multi-tenancy SaaS billing of a SaaS product. Are we talking about many users using, for example, a service running on one pod?
I mean, it's kind of like the chargeback, right? So chargeback would be you have a bunch of teams and departments, and you're going to charge them. The kind of extreme version of that is you have a bunch of customers that are using your service, and you've backed it by Kubernetes, and however, say they get a namespace per tenant or something.
Yeah. So namespace per tenant, we actually have users, I forget who are doing this right now, where they're providing namespace as a service or cluster as a service, right? And as long as the everything is being broken down by a Kubernetes concept, right? So each tenant gets a namespace, as you said, or each tenant gets a label. We absolutely see people in the wild doing chargeback and even chargeback plus X%, using our data. It gets a lot harder if you're like providing a SaaS product, but everyone is interacting with the same pods, and you want to share the cost of the pod by like the amount of requests they've made to the pod. That's way harder, and is not like natively supported. But I suppose you could figure out some voodoo if you had another data source.
Toss even more namespaces in that shared column and just add it up that way, right?
Yeah.
Is it something that either you via professional services or do you have partners that you have that work with customers that are interested in doing that, like an actual full-on implementation of that kind of solution?
Yeah. So when you buy the enterprise like tier of the product, there's a lot of enterprise support that comes with that, which includes like helping you with custom integrations, or hey, we want to charge back in this way, and we'll give you some support there. And plus, like if you want extra help, I think we're starting to do a little bit of professional services for people in that camp, but it's a pretty small percentage of what we do.
Gotcha.
Oh, I guess I can show one other thing off. I'm going to kill this for a second. I can show you a neat. We do have a CLI too, if we're among friends.
Yay.
So if you like that kind of thing, this was like my first project. Okay, that does not format well. Hold on. So this is like one of my first projects I did at the company. Is like, if you remember that cost allocation view, which is like cost by namespace over the last like 7 days. This is that over like the past 1 day on one of my clusters. There's all sorts of flags. Like we can like show CPU, and we can get like our CPU cost and efficiency. We want this historical, I think, and things like that. It's great fun. You can do. Get this from Crew. If you're aware of Crew, it's pretty sweet. It's basically a package manager for kubectl plugins, which kubectl cost is one of those. kubectl cost basically just talks directly to Kubecost API in your cluster, and it uses the same API that the front end uses and just produces a tabular in-terminal format, because I like that kind of thing, and I think some other people do too. No, it does not need more YAML. No, I reject you. Please.
What about, maybe you're gonna, you are loved, Todd, come on. What about, and maybe you're gonna talk about it, but what about the actual like budget? So like you could say, hey, you get a $120 budget, either you get an alert, or we maybe even send off something that says, nah, we're not going to let any more deployments, or we actually kick everybody off, in that. Do you do some budgeting type stuff?
Yeah, so I briefly mentioned alerting in the slide deck. We've got it as a feature in the UI. I've just managed to close that browser window. I can pull it up for you, but basically the summary is, you build a report or a set of conditions, and you say, hey, if the spend in namespace X exceeds this threshold, I want you to send somebody an email, or I want you to send a Slack notification. Or if the efficiency, which is like related to idle, it's like the efficiency of a given namespace or label or whatever Kubernetes concept dips below a certain value, I want you to send somebody a Slack message or an email. So we have like an alerting thing, but we won't just evict. We don't have automation that'll like evict people. You could probably set up like a cron job that like hits the Kubecost API every once in a while and just like take someone out of the cluster.
The kill switch.
Yeah, you could do that, but we don't provide that as a service because that sounds scary to me, to be quite honest.
Maybe this was asked, or maybe in a different way it was asked, in the sense of, do you have things that, you talk about the recommendation stuff, and Greg was asking a little bit about that from the API, but do you have stuff that actually helps with the sizing of, the resource? Let me say it this way. So like Argo or these others that could adjust the resources that people don't, like you said, people do not know how much CPU or memory they actually use. They just,
No, they don't.
And is there something that actually over time you can say, hey, I believe in Kubecost, so therefore in Argo or whatever, automatically move that one down in this namespace, because whatever they said, this is what we want you to have for the resource allocation.
Yes. So
Really
we have,
yes.
yeah, we've seen some customers who have bespoke tooling. I don't know what CD tool they're using. We also have a specific integration that I mentioned with Spinnaker that does exactly what you're talking about, where it'll deploy the workload, it'll wait for a little while, and it'll say, hey, Kubecost, is this workload based on its usage so far over requesting? And then if Kubecost, responds to the affirmative, it'll just take that recommendation and apply it in the cluster, just sort of automatically.
I've seen a lot of the similar tools that try to do that. I've seen AI tools and things that try to also kind of dynamically help you size your stuff, and a lot of it is done with webhooks, because it's so hard to integrate with the way people want you to change. Like it turns out 99% of the time, like if you just go around changing deployments, it's a bad idea.
Yeah.
Even though it's cool in demos and nice and easy, like nobody in the real world that you're selling these tools to wants you to just mess with their deployments. But I see webhooks as a pretty common, like, we'll send you a webhook when we think we have a new hint for you, and you can decide what to do with that.
Yeah, so you can do more graceful shutdowns and things like that.
Yeah, send it through your pipeline to apply that change or whatever you want. But
yeah, so I don't know. I know the people using custom integrations are like super deep into it, and I don't know. I haven't worked directly with them, so I don't know how exactly they're using it, but it may be a system like that. Have any of your customers used Kubecost only for optimizing their CI/CD pipelines, i.e. containerized CI in Kubernetes? Oh, I don't know.
That's kind of what I was asking.
But yeah, the CI/CD pipeline optimizing itself with Kubecost. I don't know.
So you'd at least get a cost of it, right? Like if it's in a shared environment, you could put a dollar amount next to it.
And if you don't want to automate it, like I'm certain people have sort of saved money on their CI/CD in Kubernetes, but I don't think they've had the CI/CD pipeline optimize itself live, because that sort of has the problem that if you edit yourself while you're running, you might just stop running, and that can, depending on how stateless you are, because I do think it's a continuum, that could be a problem.
Well, or even just saying this is how much it costs to do a C++ build versus a Go build versus a Node build or something like that. Like getting, even $1 per minute of build time, having that kind of quantized is a piece of information.
I think people are totally doing that. I think it's, if you're clever with your like workload tagging and stuff like that, if your CI system can do this, if the pod is like tagged with like the team who, if the build is running for or something like that, which I imagine you could do, you could actually say, hey, this team is spending this much on CI, which is pretty neat, I think.
What about like HPA and setting the kind of the thresholds of those? Have you had people look at that and do some analysis?
Yeah, we're currently thinking a lot about autoscalers and how we can best work with them, because I think, I don't know, I'm of the take that if we can all work on sort of the same common format, that would be really ideal. So like, how do we, in theory, integrate with like the cluster autoscaler, with like our cluster sizing API? Like, can we inform it with better heuristics? Can we inform the HBA with better heuristics? It's hard. I can't say anything like definitive, but it's very interesting. Now there are 11 standards. Yes, the state of the world.
Do you currently collect information out of service meshes or just from like node level? Specifically interested in, because it came up today, when a pod sends traffic, it might be charged one of 3 different rates, depending if that was inside the zone, between zones, between regions, or to the internet. Is that something that you currently have insights into, or a path to even get data for it? Because I assumed it would need some sort of like net flow data to be able to categorize it at that level.
Yeah. So I can't speak at great length about network costs, but I can say that we do differentiate traffic like within cluster, within region, like to the internet, that kind of stuff. And that maps very nicely to what you actually get billed for in the billing report. So we can make, cost accurate claims about what your network costs were.
Is that all the way down to the pod level, or you just say, well, this node got charged this much in this hour, so all the pods on it are getting, their share of that cost?
It is. If you enable our network cost daemon set, it is to the container level.
Interesting.
Sweet. Very
Yeah.
cool. It does have its own limitations, of course, but we're continually adding features there because I think we've heard a lot of demand for it. But yes, it is down to the container level because we have our own daemon set that does very smart things like watch contract, and will eventually use better things to keep track of where network costs are going.
And does that work in a world where Istio's doing MTLS and all of its fancy things still as well?
I cannot speak to great length about service meshes. MTLS is super cool, but I have no idea how well we do or don't integrate with it.
Well, I have a customer that I will probably send your direction immediately, since they were very interested in what was costing so much for, egress costs tripled, and having to figure that out is not an easy task usually.
I think that would be a learning experience for both of us. If it works out of the box, that would be sweet. I suspect there might be a little bit of tweaking, but yeah, it's a continuing area of development for us. But it works really well for a ton of our customers in terms of like the regular deployments I'm used to. Service mesh is still pretty new for me.
I don't know if this makes sense either, but sometimes you talked about the idle connection type stuff, saying, hey, maybe this thing's not really taking any traffic. What about the opposite? It's not like DDoS detection, but it's almost like, wait a second, this pod is getting way too much traffic over a period of time and costing us because of either HPA or whatever. I don't know if that makes sense.
I get the idea that you're talking about. This is not something we do right now. And a lot of it's just like a data problem where our like core tenant is we want to tell you cost data for a week, a month. We want to tell you over like 6 months or a year if you have that depth of data. But as a result, to get performance, especially in, we talk about people who have like 250,000 pods that we need to like deal with. And the sort of data source that's best for answering questions about 250,000 pods, Prometheus, sure, rookie numbers. There are people with many, many more that we work with. And they can't just run a 30-day Prometheus query. That's gonna break. So we sort of put stuff in a much better format. We like batch requests in small windows, but that means we have aggregatable data statistics, like aggregatable summary statistics, which means you lose the granularity you need to make like real-time decisions about like load is spiking abnormally. We can make a couple of guesses, but nothing complex, and it's not in the product right now.
Okay. It's almost like what Tom was talking about too, is that sometimes we DDoS across services within cluster. So I guess you could kind of make some detection of that as well.
I mean, you could do a rough thing on cost, like, holy cow, like tell me if the cost of any service like quadruples. And if it does, maybe you have something you should look into. But we just can't make like super granular stuff like below the hour or day level just because of how we aggregate the data to have any sort of reasonable performance at scale.
Okay, thank you.
Anything else?
You're at the end of your presentation and demo, right?
Yep, all done.
Wow. Yeah, any more questions? This has been incredible. I've really learned a lot and gonna have to try it out. So any other questions before we, Michael lives on the East Coast, so we owe him a nightcap of some sort.
Oh, that's quite all right. I can, last thing I can do is I can just pull up the last slide of the deck, which has some contact info. And I will also send you the slide deck, which you can share with this group
Thank you.
tonight or tomorrow. Let me see. Yeah, so if you want to talk to me specifically, I'm happy to talk about the product. You can hit me up at michael@kubecost.com. That sort of hosted SaaS version is in closed beta. So if you're super interested in that kind of thing, you can, talk to me directly. Like I said, basically everything I showed you, barring things I call those like specifically enterprise features, You can really just helm install. You can go to kubecost.com/install to get it going. You let us know what you think. We have a community Slack. You can hit us up on email. You can hit us up on GitHub. Check out some of our source code. Make a contribution if you like. Open an issue if something's broken. All that information is at kubecost.com. Yeah. Thank you very much for having me. It's great to be here, and I'll get the slide deck to you tonight.
Thank you so much. I wish we could all clap at the same time. I'll do it for the group, but we appreciate you, Michael. And
Thank you.
Love to have you back. Maybe as things progress in the near future, in the future. So
Absolutely.
All right. Thank you, everyone. Be safe, and thank you again for participating. Take care.